All right, so here's number 9. It says, what is the surface gravity? And notice I have surface in quotes because Neptune, of course, doesn't have a surface. What is the quote surface gravity of Neptune at the top of the clouds, right? So all we can do is measure, what the gravity would be at the top of the clouds. The mass of Neptune is given to us as 1.02 times 10 to the 26 kilograms, and the radius of Neptune is given to us in kilometers, 24,764 kilometers. All right, and there's the answer. The answer turns out to be 11.1, but we're going to prove that now. All right, so the first thing that we have to do is we have to change the radius to from kilograms, right? It's already in kilograms to grams, and so you basically just replace the k with a times 10 to the third, right? So that's a simple, quick way to do that. So here I'll just show you that. So it's 24,764. And it's here. I'm going to prove this. All right. So it's kilometers, and in 1 kilometer, there are 10 to the third. That's a 3. It's supposed to be a 3 meters. All right. So the kilometer part cancels, and so this becomes, 2. It's the exact same number, 24764. But now you put a times 10 to the third. All right, I like to use the E3. And so now that's in meters. All right. So that's important because the equation for the surface, or for gravity, in this case, it's this. I'm using the word surface very loosely because, of course, Mercury. I'm sorry. The wrong planet. Neptune does not have a surface, right? It's an ice giant. It's an ice. We say that, and that would sound like it has a surface, but it really just has clouds that just get thicker and thicker. All right. At any rate, the gravity from some distance r from the center of the planet is equal to. So here's the formula, of course, big G times the mass in kilograms divided by the radius squared, and the radius has to be in meters. All right, so let's put the numbers in. So it's 6.67. Right, that number is always the same, times 10 to the minus 11th times. All right, so the mass of Neptune is given to us as 1.02 times 10 to the 26th. All right, and that's kilograms, and that's correct. Now we divide by the radius, but it's got to be in meters, which is what we just did. So it's going to be the radius squared. That is 24764 times 10 to the third, and we have to square that. All right, so then that's really all you have to do. Put that in your calculator, and here we go. All right, so here, let's clear that. All right, so it's going to be 6.67 times 10. Oops, yeah, there it is. Times 10 to the minus 11th. All right, and then times 1.02 times 10 to the 26th kilograms, and then we divide it by 24,24764 times 10 to the third, and we have to square that. All right, so you hit the square button and then say equals. All right, and so there it is, right? So the answer turns out to be 11.09. They tell us to round it to one place past the decimal, so that would be, you would round the 0 up 1. So the answer would be 11.1. And of course, the units are meters per second. squared. All right. So compare that to the Earth. The Earth's very famously has a surface gravity of 9.8 meters per second squared, which was first measured by Galileo 400 years ago. All right, so here's number 10. It says the speed at which a meteoroid hits the atmosphere is roughly the speed of Mars as its orbit in its orbit. You might say that Mars hits the meteoroid. And of course, I mean this is an oversimplification, but it's actually really close to being true. All right, anyhow, what is the speed of Mars's orbit? Express your answer in kilometers per second, round to one place past the decimal. Use the average distance between the Sun and Mars as 1.52 astronomical units. All right, and there's the answer, of course. So the answer will come out to be about 24.2 kilometers per second. All right. So now how do we do this? One way to do it, of course, one way is to realize the speed of Mars. Let's see. We have to figure out first of all the period. How many seconds does it take Mars to go all the way around the sun? And so with that, we can easily use Kepler's third law, which says a cubed is equal to p squared, right? Where p is the period. All right, let me erase that little part right there. I didn't mean to do that. All right, so whoops, come on. All right, there we go. That's supposed to be a P. Doesn't really look like a P. All right. So anyhow, so P, if we solve for P, is going to equal the square root of a cubed. All right. So this is going to be the square root of, and I'll just put in what a is. A is 1.52, but I have to cube that. All right. So that's going to give us the answer. Or that'll give us the period, which we need to know. We need to know how much time it takes Mars to go all the way around the sun. All right, so here we go. I'll clear this. All right, so 1.52. All right, raised to the third power. All right, is equal to so that's that, and then we take the square root of that. So it takes Mars about 1.87. Let's just say that 1.87 years. So 1.87 years. So we have to get that down to seconds, and then the way that we do that, of course, is we just say in 1 year there's 365.24 days, and then you know that in 1 day there's 24 hours. I shouldn't have done. And then here. So then you say 24 hours. In 1 hour there is 60 minutes, and in 1 minute there's 60 seconds. All right, I just wrote it this way because I was running out of room. All right, so here, let's figure out what that is, since we already have the amount of time it takes to go all the way for Mars, the planet Mars, to go all the way around the sun. So it's 1.87 years. Well, I mean, that's the unrounded version there. All right, so I'm going to say times 365.24. Right, so that's the number of days in a year, and then times 24, the number of hours in a day, times 60. Times 60 times 60, right? Because you got to do this bottom part right here. Or 60 squared is another way to do it. Equals. All right, so this is the number of seconds. So this is our period. All right, so yeah. let's see, it's going to be 5.9, let's see, times 10 to the, so you see there's the 750.7. All right, so it's going to be times 10 to the seventh. All right, so it'd be 5.9, roughly 5.9 times 10 to the seventh seconds. All right, so now we're going to use that. We'll use the exact number in just a second here. We're actually really close to being done. All right, so I'm going to store that. Just remember that that's in. So that's the number of seconds. All right. The other thing that we have to do is we have to figure out what distance does Mars travel, right? And so remember velocity. So let's. I didn't mean to do that. Velocity is distance divided by time. But for a circle, right? Anything moving in a circle, um, if you know the radius of the circle, there's the distance that it travels, which is called the circumference, is that's supposed to be an r, is 2 pi times the radius. So it's going to be 2 pi times the radius. Now we don't have the radius we have it in astronomical units, but we're going to want to change that. All right, so let me do. I'm kind of getting squished up here. Here, I'm gonna do this right here. So the velocity. We'll just close that right now. The velocity is going to be 2 pi times the radius, which is currently in astronomical units. 2 pi times 1.52, AU. But I know that in 1 AU, there are 150 million kilometers times 10 to the sixth kilometers. All right, so see the AU's cancel, and then then I divide by the period, which is this number right here, which I stored in my calculator, roughly 5.9. I'm going to use the unrounded version, 5.9 times 10 to the seventh, all right, seconds. Okay, so that's that, and then that'll solve it. All right. All right. So again, that's already in my calculator. Let me move this over a little bit. So this is going to be. So let's say. So it's going to be. Well, let me convert this first. So it's going to be 1.52 times 150 times 10 to the sixth. All right, and then we're going to I mean, you could have done the 2 pi first, but I just wanted to do so times 2 times pi. All right, so this is what goes in the numerator. All right, so this is the number. Oh, yeah, I got to hit equals. All right, so it's going to be let's see. So that would be 1, 2, 3, 1, 2, 3. So 1.4 times 10 to the ninth divided by the period. All right, so that's already my calculator. All I have to do is say divided by. Remember, I stored the period. So see, this is in kilometers. So it's 100. So 1.4 times 10 to the ninth kilometers divided by what's in what I stored, which is the period in seconds. All right, and so that's what it comes out to be. All right, so 24.22. It says to round it to one place past the decimal, so I'm going to round that to move that over here, 24.2. All right, so this is 24.2 kilometers per second. So that's how fast Mars is orbiting the sun, which is how fast, if you kind of think of the meteoroids as moving more or less, they're not moving very fast, so they're almost at zero. And when they collide with Mars, it's really the velocity of Mars that you're colliding